Hi guys, this is Shockmaster. I'm here with a quick video on a topic that's been bugging me for a little bit. I see these videos on YouTube about tablets called Jitter test. There's a bunch of them, and it's really stupid. Um, I say no to Jitter test. It's really ridiculous, and let me explain why it's ridiculous. Um, First, let me show you what Jitter test is. So it usually involves a ruler, an active digitizer of some sort, a fine pen or brush, finest one they can muster, and then what they would do is they would put the ruler, and I can't do it right now because I'm holding a camera with the other hand, but what they would do is like go really slowly with the ruler, and really slowly, and they end up producing things like these lines here. It has to be diagonal, obviously, because what fun is vertical, no jitter. So they will go slowly, and you see this kind of result, and they go, "What is going on? I'm using a ruler. I'm going really slow, so I'm steady, but it's using these producing these wavy lines. Versus if I go fast, it'll be straight." This is stupid. This is something wrong with my tablet. What's going on? Is it a software problem? Hardware problem? This is no bueno. And they would cry. Well, okay, someone won't cry, but they would complain about it. When will they solve it? When will they fix it? Guess what? They're never going to be solving this problem because it's not a problem. It just means you don't know how these things work. So let's talk about a digitizer grid. Okay, whether it be something like this, which is Wacom EMR board. It's got a grid. It's actually got a really fine grid. It's got 500 lines per inch or more grid. Or something like N-Trig that has, or any kind of a projected capacitive touch with active digitizer pen. But they all have these grid system, right? And so what it does is there's grids going this way, there's going vertically and horizontally, and that basically helps you to tell the computer where the pen is. If for the sake of argument, let's say this is almost pixel size. Okay, this like let's say that's a pixel, and the grid is almost perfect match for a pixel. Probably not going to happen, but let's just say that's the case, which means a pen tip is like this big or something, right? So let's say pen tip goes from there, maybe even bigger, but there goes from there to there, right? Draw a really straight line. If you go slow, well, let's backtrack a little bit before I say this. All these pens, whether it be Wacom or N-Trig, they all talk to the digitizer board X amount of times per second. It's what makes them active digitizers. They're actively pinging the board, or the board is pinging the pen, vice versa. In the case of Wacom, I don't like that brush. Hold on, give me a second. Let's see. Still, okay. So, in the case of Wacom, there you can see that nicely. We're talking 133 hertz. For N-Trig, I'm not 100% sure about this, but from what I remember talking to the N-Trig technician, I believe it's 120 hertz. Either case, it's really fast. So every second, the Wacom digitizer board underneath the LCD is pinging out to the pen 133 times. Whereas N-Trig pen, it's the backwards with N-Trig. The pen is pinging the board, the touch layer, 120 times per second. Either case, it's a lot of times per second, right? So, okay, let's keep that in mind. So this is called polling rate. Okay, polling rate. 133 times per second, 220 times per second. A lot of polling. So we're back to this pen scenario. Okay, here's a pen tip, really big. It goes from there to there. Okay, this is the grid. Okay, let's say for the sake of argument, it took the pen to go from here to here 1 second. Let's say this is N-Trig, just to make it math easier for me. Which means between, okay, that's ridiculous. Let's 1 second, but no, 0.1 second. Okay, from here to here, it took 1/10 of a second. It's a really short line. Okay, even then, so remember the polling rate for N-Trig is 120 hertz. So 1/10 of that is going to be 12 times. So between this point and this point, there should be 10 points. Okay? Do you hear what I'm saying here? So even though this line only took 1/10 of a second, there is 12 points making up that line. Now remember, this is the grid. The point can't be here or here or here, 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 here. It's going to be here. They're intersections. Here, 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 nah. What do you see? Holy crap, it's a wavy line. Do you hear what I'm saying here? It's too much data. Remember in math class, what's the shortest distance between 2 points? Boom, boom. Straight line. So if you want a straight line, you don't want to give it lots of data, because if you got 2 points, straight line. If you got 3 points, not a straight line. 4 points, no. You know, that's just math. If you want a straight line, you want to give it less points. Which means, because these things pull so much per second, you want to go fast. You want to draw a line fast. If you draw a line slow, it's wavy. If you draw it fast, straight. Fast, good. Slow, bad. Okay? So, don't go slow. It'll jitter, because you're going to give it more data. There's going to be more data. The grid's pretty fine. So it's going to tell you, like, well, okay, so you were here, but you're kind of here, you're kind of here. It's going to tell you all those things. And it's going to feed that to the computer, and the computer is going to tell it to software, and software is going to go, well, I got to use all that line. Well, actually, if the software is pretty smart, it'll ignore a lot of the lines. But if you go slow, you can't ignore it because you're drawing freaking slow. So it's going to try to utilize all those lines. If you go fast, it's going to throw a lot of the lines and say, you know what, you really meant this. Right? It's just simple. It's simple logic. Do not do any more jitter test. It is stupid. Okay? You'll jitter if you go slow. Don't draw slow. Nothing to be gained by drawing slow on active digitizers. Period. All right. Hopefully that was helpful and not too condescending, but it really bugged me, so there you go. Next time I hope to have a little more useful video. So see you next time. Bye.